Book Summary: The Brain, The Story of You by David Eagleman. Enjoy the video. Please subscribing to my channel for more great content like this. You'll be notified when I upload new videos. Introduction. Our brains are an integral part of our existence. They control our thoughts, decisions, emotions, and define our individuality. This book explores the inner workings of our brains and questions the nature of personality. Eagleman uses neurological research to provide insights into brain function. This summary will cover the unique brain structure of London taxi drivers, how smell affects moral judgments, the unexpected effects of Botox on personality. For the example, 1. London taxi drivers' unique brains. London cabbies have distinct brain features due to their extensive knowledge of the city's streets and routes. Their hippocampi, responsible for spatial memory, are larger than average. This growth results from years of practical application of the knowledge. 2. The impact of smell on morality. Surprisingly, our sense of smell influences our moral compass. Understanding this connection sheds light on human behavior. 3. Botox and personality. Botox injections can affect more than just appearance. They may alter personality traits, revealing the brain's intricate connections. Chapter 1: The Evolving Brain. People change constantly throughout their lives. From a neurological perspective, this change may be the only constant in human existence. Consider how different you are now compared to your 2-year-old self, or even yourself from 2 years ago. These changes occur due to evolving connections in our brains. Synapses, which transmit information, change as we age. We retain connections that are frequently used and lose those that aren't. For example, in childhood, these synapses help us learn and understand speech through repetition. This process also applies to our personalities, as new experiences and information create new neural connections. This adaptability is called neuroplasticity, the brain's ability to learn through repetition. While children's brains are more adaptable, adults can still learn new skills. Researchers at University College London studied this concept by examining London taxi drivers. They discovered that these drivers had larger hippocampi, the brain region responsible for spatial memory, compared to the average person. This difference is attributed to the knowledge, the extensive memorization of London's geography required for their job. The daily use of this information effectively exercises and enlarges their brains. Chapter 2: How your brain interprets sensory data shapes your perception of reality. Our understanding of reality is subjective and can differ from person to person. This concept becomes clear when we examine it through neuroscience. Optical illusions demonstrate how our brain can rapidly change its interpretation of visual information. Our perception of reality is not solely based on logic. It is influenced by our sensory organs, which control our perception of sight, taste, and smell. The case of Mike May, a Paralympic skier, illustrates this concept. May lost his sight at age 3. A surgery to restore his vision in his 40s had unexpected results. Having adapted to blindness for most of his life, May's other senses had compensated by becoming stronger. When his sight was restored, his perception of reality was disrupted. The sudden influx of visual information overwhelmed his brain. Contrary to his expectations, he found the world frightening and overwhelming. He struggled to recognize his family visually and found skiing more challenging. This confusion occurred because May's brain had not learned to process visual information effectively. Research shows that sight is not simply like a video camera relaying information to the brain. It is a collaborative effort between the eyes and the brain. If the communication between eyes and brain is disrupted, our perception of reality changes accordingly. May's case demonstrates how the brain's adaptation to rely on other senses made learning to process visual information more challenging. This example illustrates the complexities of brain function, but there are many other fascinating conditions that can result from minor changes in brain wiring. Synesthesia is a perceptual phenomenon where sensory perceptions are mixed in the brain. In synesthesia, brain areas that typically respond to visual stimuli may also activate when hearing music, leading to experiences like tasting words or seeing colors when hearing music. Synesthesia is not a disability but rather an example of how brain processing is closely linked to sensory organs, affecting our perception of reality. Chapter 3: The Subconscious Mind's Role in Decision-Making. While we make many conscious decisions daily, neurologically, our subconscious mind plays a significant role in decision-making. This subconscious control is beneficial, as it allows us to perform routine tasks efficiently without conscious effort. Our brain processes many daily tasks automatically, as they are practiced skills that can run on autopilot. We often perform better at tasks when we don't overthink them, as demonstrated by Austin Neighbor, a young champion sport stacker. EEG tests showed that Austin's brain remained at rest while performing complex stacking tasks, unlike the author who expended significant mental energy on the unfamiliar activity. This autopilot mode is not laziness but efficiency, as studies show we're more likely to make mistakes in familiar tasks when consciously engaged. A study on baseball players revealed they hit the ball without conscious decision, which is advantageous given the speed required for accurate timing. Evolutionary psychologist Jeffrey Miller's research on strip dancers found that those ovulating earn significantly more, suggesting subconscious male responses to subtle physical changes. Other studies support the idea that our subconscious influences decision-making. For example, unpleasant smells can negatively impact first impressions of people. Holding a warm drink can positively influence descriptions of relationships with others. These findings demonstrate that our brains are highly responsive to priming, where sensory perceptions unconsciously influence our decision-making processes. Our subconscious mind processes a vast amount of information that our conscious mind cannot handle. This allows us to make quick decisions in complex situations. The subconscious mind's influence extends to various aspects of our lives, including social interactions, consumer choices, and even moral judgments. Research in neuroscience and psychology continues to reveal the extent of our subconscious mind's role in decision-making. Understanding this subconscious influence can help us make better decisions by recognizing potential biases and external factors affecting our choices. While we cannot completely control our subconscious processes, awareness of their existence can lead to more informed and deliberate decision-making when necessary. The interplay between conscious and subconscious decision-making highlights the complexity of human cognition and behavior. Recognizing the power of our subconscious mind can also help in developing habits and skills, as repetition can automate complex tasks over time. In professional settings, understanding subconscious decision-making can improve team dynamics, leadership, and organizational processes. As we continue to learn about the brain's decision-making processes, we may develop new strategies to harness the power of our subconscious mind more effectively. Chapter 4: Instant Gratification's Influence on Decision-Making. Our decision-making process involves the interaction of sensory and emotional cues in various brain regions. When making choices, we activate multiple sensory and emotional associations related to the options. This process can create a feedback loop with positive or negative associations, influencing future decisions. Studying cases where brain-body communication is disrupted helps us understand normal brain function. Tammy Meyer's case, where brain damage affected her ability to sense physical and emotional states, illustrates the importance of brain-body communication in decision-making. Our brains often prefer short-term satisfaction or instant gratification over long-term rewards. This preference for immediate rewards can lead to choices that conflict with long-term goals, such as breaking diets or skipping exercise. To counteract the tendency towards instant gratification, one can use a Ulysses contract. This concept, named after the Greek myth, involves creating self-imposed restrictions to prevent giving in to temptation. Implementing fail-safes, such as accountability partners or removing distractions, can help maintain commitment to long-term goals. These strategies can be effective in overcoming the brain's bias towards instant gratification and promoting more beneficial long-term choices. Understanding the concept of instant gratification can help individuals develop more effective strategies for self-control and goal achievement. Neuroscientific research shows that different brain regions are involved in processing immediate versus delayed rewards. The prefrontal cortex plays a crucial role in overriding impulses for immediate gratification in favor of long-term benefits. Developing this ability to delay gratification is often associated with better life outcomes, including academic and professional success. Various techniques can be employed to strengthen willpower and resist immediate temptations, such as mindfulness and cognitive reframing. Environmental factors also play a significant role in our decision-making processes, highlighting the importance of creating supportive surroundings for achieving goals. Understanding the neurological basis of instant gratification can inform public policy and educational strategies to promote better long-term decision-making. In the digital age, the constant availability of instant rewards presents new challenges for self-control and focused attention. Recognizing the influence of instant gratification on our choices can lead to more intentional and balanced decision-making in various aspects of life. By consciously addressing our tendency towards instant gratification, we can align our actions more closely with our long-term goals and values. Chapter 5: The Brain's Role in Social Interaction. Human beings are inherently social creatures, as evidenced by our brain activity and our affinity for social media. Our brain facilitates social connections through empathy, which is the ability to understand and relate to others' emotions. From a neurological perspective, empathy occurs through mirroring, where we reflect others' facial expressions to understand their thoughts and feelings. To investigate the importance of mirroring in social connection, Eagleman conducted an experiment comparing people who had received Botox injections to those who had not. The study measured facial muscle movement while participants viewed pictures of various facial expressions. Results showed that the Botox group not only displayed less expressiveness but also struggled to identify others' facial expressions, indicating lower empathy levels. Additional research has shown that empathy plays a crucial role in determining who we believe deserves our support. An experiment at the University of Leiden in the Netherlands further illustrated this concept. Participants were shown images of homeless and non-homeless individuals while their brain activity was monitored. The study found significantly lower brain activity when participants viewed images of homeless people compared to non-homeless individuals. This low empathy response suggests that participants subconsciously deemed the homeless individuals less worthy of empathy or support. These findings highlight the complex relationship between brain function, empathy, and social behavior. Understanding the neurological basis of empathy can provide insights into social dynamics and decision-making processes. Research in this area has implications for fields such as psychology, sociology, and public policy. The brain's mirroring system plays a crucial role in our ability to understand and connect with others. Impairments in this system, whether natural or induced, as with Botox, can affect social interactions and empathy. The study on responses to homeless individuals reveals potential neurological underpinnings of social biases and discrimination. This research underscores the importance of conscious effort in overcoming subconscious biases that may influence our empathy and social behavior. Understanding these brain functions can help in developing strategies to promote greater empathy and social cohesion. The interplay between brain activity and social behavior demonstrates the intricate connection between neurology and sociology. Further research in this area could lead to new approaches in addressing social issues and improving interpersonal relationships. Chapter 6: The Irreplaceable Nature of the Human Brain in the Age of Technology. Despite unprecedented technological advances, fears of human obsolescence are unfounded. The concept of transhumanism, which involves merging human bodies with technology, does not threaten to replace the human brain. Instead, transhumanism could enhance human capabilities, similar to how cochlear implants aid hearing-impaired individuals. Cochlear implants demonstrate how electronic devices can interface with the brain, relaying digital signals that are interpreted as sensory information. This technology suggests the potential for future innovations in brain-computer interfaces, possibly allowing direct neural access to information. The integration of technology with human biology could open new frontiers in human experience and capability. However, this integration would not make the human mind obsolete, rather, it would augment existing cognitive abilities. Computers, despite their processing power, cannot replicate human awareness or understanding. For example, search engines use complex algorithms to find information but lack the ability to engage in genuine conversation or comprehension. The power of human connection and understanding remains irreplaceable by current or foreseeable technology. The human brain's adaptability and capacity for complex reasoning set it apart from artificial intelligence systems. While technology can enhance cognitive functions, it cannot replicate the nuanced decision-making and emotional intelligence of humans. The potential fusion of technology and biology highlights the need for ethical considerations in neurotechnological advancements. As technology progresses, the unique qualities of human cognition may become even more valuable in various fields. The complementary relationship between human intelligence and artificial intelligence is likely to drive future innovations. Understanding the distinctions between human and machine intelligence can inform more effective development of AI and human-computer interfaces. The integration of technology with human cognition may lead to new forms of problem-solving and creativity. As we explore the possibilities of brain-computer interfaces, it's crucial to maintain a balance between technological enhancement and preserving core human experiences. The future of human-technology interaction will likely involve a synergistic relationship rather than a replacement of human capabilities. Continued research in neuroscience and technology will be essential in navigating the evolving landscape of human cognitive enhancement. Summary: the human brain is fundamental to our understanding of the world, yet our comprehension of its functioning is often limited. Gaining insight into concepts such as neuroplasticity, empathy, and sensory processing can enhance our understanding of brain function. This knowledge provides a deeper appreciation for the intricate processes that govern our daily experiences and behaviors. Understanding brain function can boost confidence in our ability to learn new skills and retrain our cognitive processes. The end. Thank you for watching. Please subscribe, like, and share. See you next video.